Hi, meet Erica. She's a small business owner who owns an retail store. As time flew by, she wanted to scale her business and started an online retail store. She started observing that there was no improvement in her customer base, which led to decrease in business. Basically, her business plan was not performing as she expected. One day, she happened to meet her friend Angelica, who works as a developer in an e commerce company. As Erica was unhappy about her business earnings, she happened to share it to Angelica. Angelica suggested that in order to scale her business, she has to have an e commerce platform along with a good recommendation system in place. The website's recommendation engine can not only suggest things to customers and save time looking for products, but it can also assist business owners in cutting back on pointless sales activities and management costs. Utilizing the recommendation system effectively can streamline the user's purchasing experience, boost shopping contentment, assist businesses in executing more accurate marketing tactics, boost corporate marketing revenue, and boost sales profits. Erica implemented the recommendation system in her e-commerce platform and saw an increase in her profit margin as consumers engaged and bought more products from the new strategy. Now, let's take a closer look as to what worked for Erica in her e-commerce business. Architecture. User interface. This is the front end of the system where users can browse and search for products, view product details, and make purchases. Product catalog. This is the database of all the products available for purchase on the e-commerce platform. User behavior tracking. This component tracks the actions and interactions of the users on the platform, such as the product they view and purchase, the search queries they make, and the time spent on each page. Personalization engine. This component uses the user behavior data to create personalized recommendation for each user, such as recommended products, categories, and brands. Recommendation algorithm. This is the algorithm that processes the user behavior data and generates personalized recommendation for each user. Data storage. This component stores the user behavior data, product catalog data, and personalized recommendation for future use. Integration with other systems. This component allows the recommendation system to integrate with other systems such as the payment gateway, fulfillment center, and customer support to provide a seamless user experience. Collaborator filtering versus content filtering. Main idea of collaborative filtering is similar users who have bought the same product in the past are clustered, then recommended the new product consumed by her to him. The main idea of content-based method is to try to build a model based on the available features that explain the observed user item interactions. Next, let's look at the pros and cons of recommendation system algorithms. One is the content-based recommendation algorithm. The strength is that the recommended results are simple and easy, but the weakness is that they are unable to recommend new users as there are too many classifiers. The next one is collaborative filtering recommendation algorithm. The strength is the high level of individualization and systemization, dealing with unstructured objects and diverse recommendation objects. But the weakness is it can't scale quickly. Data set quality requirements are high and sparsity is an issue. Rule-based recommendation algorithm. Quick discovery and non-professional are its strengths, but its weaknesses are rules are hard to find, synonymous issues with similar products, and low degree of personalization. Recommendation algorithm based on utility. no sparseness problem, sensitive to changes in preferences, non-product characteristics are its strengths. But the weaknesses are it rely on user manual input, static selection. The next is the knowledge-based recommendation algorithm, demand product formation mapping. Non-product attributes are its strength, whereas its weaknesses are knowledge is difficult to obtain, static recommendation. Now, of all the pool of algorithm, let's find the choice of algorithm. Combining recommendation algorithm is a common practice to predict particular issues because recommendation techniques have some pertinence. In order to investigate the prospective purchasing requirements of new users, we here use a collaborative filtering method based on user data characteristics. Recommended system workflow. It can be seen in the figure that the user visits the website page, sets the user's sliding window size, grabs the page information of the user's current visit period through the client server, and then performs path clustering and similarity matching through the recommendation system to obtain the parameters of the recommended page. The backend server retrieves the specific information of the recommended page from the database and returns it to the client server, and finally displays the product page recommended by the user system through the front-end page. Analysis of the algorithm. The table shows the score of 0 to 3. It indicates no interest, favorites, shopping carts, and have purchased respectively. For example, user A rates X with a score of 0, indicating that the user A is not interested in the product, and rates product C with 3, indicating that the user has bought the goods. However, the approach of determining the similarity between users only based on users' assessment of the product has become extremely inaccurate in the setting of a fast expanding amount of data. At this time, it seems more important to analyze the user's access behavior characteristics. The information about a user's visit to a website is primarily derived from the server's information storage of that user's visit process. The product evaluation system effectively integrates the analysis result of the two to form more useful common characteristics of user behavior by sorting and combining the user's behavior characteristics, which include a large amount of characteristic information such as the number of page visits and access time. The result of the study is more accurate and insightful in the setting of massive data than the conventional collaborative filtering technique. The aforementioned investigation shows that the recommendation algorithm based on user behavior characteristics takes into account the user's page access time and the number of visits in its entirety. COR reflects the similarity between users U and V. Data processing and model training. The experimental data comes from a data set composed of data from the backend management system of the Erica's e-commerce platform. After sorting and cleaning the access data set, 10,000 rows of data are finally selected for training, of which 8,000 rows are used for training set and 2,000 rows are used as the test set. Figure 2 illustrates how the difference between the anticipated value and the true value is rapidly closing as the number of matched page increases. This demonstrates that there is a higher degree of temporal matching when the projected users and the cluster users visit the page. The higher it is, the more accurate the recommendations are. Similar to that, figure 3 below depicts the product coverage. Figure 3 illustrates how, for varying sliding window matching numbers, the converge of recommended items fall as the number of matched product pages increases, since the range of recommended product page is constrained. According to the principle of similarity, it is getting smaller while the accuracy rate is increasing. Conclusion. This algorithm extracts the characteristic behavior of users when visiting website pages, uses the category and time of visiting product pages, and calculates the matching degree of the visited pages between users and the score value of recommended products. A more realistic similarity between users is obtained. The accuracy of recommended product pages is improved and the performance of the recommendation system is improved. Thank you.